Hello, class. Continuation from section 5.1, which talks about the introduction to polynomial equations. So this recorded lecture will focus on one of the attributes on analyzing polynomial equations. And depending on what book you work out of, sometimes it's called leading term test. And sometimes it's called end behavior test. I believe our book uses the term end behavior. But the idea is this, and then we'll walk through the definitions. The idea is this: on a polynomial, any polynomial equation, there are the graph of the polynomial equation as x gets really big in the positive direction. And we use this idea as the limit. You'll hear the term limit sometimes. But the idea is x approaches positive infinity this way. There are two possibilities of what happens to the y value in a polynomial. Other equations are different. It just works with polynomials. And so the one idea is that y could go up this way. And so that means y could go to positive infinity as x goes to positive infinity, or the other option is it can go down. And so that would mean y would go to negative infinity. And same in the other direction. As x goes to minus infinity, which means we go to the left, right? All the way out. Same thing happens to y. It could either go up or it could go down. So there's only two choices. And what dictates what happens at the two extremes of the graph is this idea of, I like to use leading term test because you use the leading term to calculate this. Like I said, our book uses end behavior, which is the end behavior of the graphs. So let me show you the definition. So here is one definition that we use, and this is the idea of what happens at the two extremes. When x gets really big in the positive direction, this is what we use by positive infinity, and x gets really big in the negative direction. That's what we use as minus infinity. And like I said, there are only four possibilities that will happen because y either is going to be positive infinity or negative infinity as well. And so the idea is that the leading term will dictate how the graph behaves, how the equation behaves when x is really big or really small. And so when you remember this idea of leading term, what it meant was if you had an equation like this, f of x equals 6x cubed plus 1000 x squared plus 6x plus 1. And what the leading term or the end behavior test says, so our leading term is 6x cubed. And so this is going to dominate when x is really big in the positive direction or really big in the negative direction. And even that this 1000 seems big to you, if you think about it, it's when x gets really, really big, square will dominate the cubed, just like x to the fourth would dominate x cubed, and so on and so forth. And I'm not going to prove that to you, but you can think about that with just some numbers, all right? Well, what's 100 squared? Well, 100 times 100 is 4 zeros, so that would be 10,000. But what's 100 cubed? Well, you have to add 2 more zeros to that. So instead of 10,000, you get to 1,000,000. And as you see, as that number gets bigger, you're adding quite a bit more zeros. So it grows way faster. And so this will dictate what happens as x goes to plus and minus infinity. And so you could look at the book and look at these slides, and there are 4 possibilities. So I'll let you take a look at that. What I'm going to show you is this introduction of how to evaluate limits. Because for those of you that are going on your merry way in the math, it's going to be a useful tool. And this is a kind of a unique technique that I use. Engineers use, mathematicians don't like it. So, but it works every single time. So let me show you what I mean. So if we take this equation here and we want to do the end behavior. So if you think about our graph, we're going to figure out what happens to the graph way out here and what happens to the graph way out here. And there are 4 possibilities. It goes up or down at one end and up or down at the other end. And so there are 4 total possibilities. So the idea is to think about it this way. The end behavior leading term test depends on this particular term at the beginning. So if you think about it, what happens as x goes to infinity? So the strategy is you want to know what the sign of the y value is going to be. And what do we mean by sign? Well, if it's positive infinity, it's going to go up. And if it's negative infinity, it's going to go down. And remember, as x goes to positive infinity, we're heading all the way to the right. So the way you do this is you plug it in. And you say to yourself, okay, I plugged in the infinity. So you have infinity cubed, and you have multiplied by 6. Well, the 6 isn't going to do anything. But the question is, what is the sign? Is it negative or positive? Well, a number that's positive cubed stays positive, right? So if you think about this, this would be y goes to positive infinity. So what happens on the graph? It doesn't go down, it goes up. So what ends up happening is this would be the graph going that way. So what happens as x goes to minus infinity? Well, same kind of idea. 6 minus infinity cubed. So you remember, you have a cube. So that's multiplied 3 times, right? It looks like this. And you remember, if you have an odd number of negatives that you multiply together, what does it end up being? Ends up being negative, right? So this would be y would go to minus infinity. So as x heads that way to the left, what does y do? Y goes down this way. And this technique works every single time. The end behavior or leading term test is the idea of figuring out when you plug in x's positive infinity and negative infinity, what happens, i.e., what sign does the y value end up being? So let's do another one. So say like you had the function f of x equals minus x cubed plus 6x plus 5. So what happens to our graph over here? Well, as x goes to positive infinity, you plug that in, you get minus infinity cubed. So how many minuses do we have? Well, we have the 1 minus out front, and these are all positive. So you have 1 minus, right? So then y would go to minus infinity. So what happens in this part of the graph? It would go down like that. So as x goes to minus infinity, what do we have? Well, you again worry about the leading term test or the end behavior, which is the first coefficient here, leading term, and it would be minus infinity cubed. So how many minuses do you have? Looks like we have 4, right? 3 with this cubed, and then 1 out front. So an even number gives us a positive value. So this would make this go to positive infinity. So at the end of this graph, it would go out like that. Kind of see the pattern with this? Let's do one more. Say like you have f of x equals minus x to the fourth plus 6x cubed plus 7x plus 8. So our leading term, forgot to write that on the last one, sorry, but leading term is minus x to the fourth. So that's the one that we're dictating. And so the idea here is that if you plug in minus or infinity first, right? So again, let me put my little Cartesian coordinate plane. So plus infinity goes to the right. If you plug that in, how many infinities do we have? Well, we have, or excuse me, how many negatives do we have? And so we have just one negative, right? And so this would go to minus infinity. So again, this would go down in this case. So what happens is x goes to minus infinity. Well, you plug that into the leading term. And what do you get? Well, you have four negatives for the fourth power, and then 1 out front is 5, so that's odd as well. So you could see that both of these actually go down. And so over here at the end of that graph, it would go down as well. So with regards to kind of taking a look at these different equations and being able to pick what graphs go with what. And so it's a little bit harder to do with these slides, but let me try to do the best I can. So here we have 4 equations, and I'm going to show you 4 graphs that would correspond to these equations, and you would want to be able to pick what graph goes with what equation. So it's kind of like the match game. Much easier to do in a classroom environment because I could write these equations up on the board and then have the graphs up on the slides. A little bit harder to do in this. So what I like to do is first show you the graphs. And so here they are. And you can see graph A. This would be as x goes to positive infinity, y goes to positive infinity. See how that works? And so you can see these are 4 different orientations. So instead of walking through our little match game that we would do if we were doing this class in person, let me just show you the answers. And let me walk you through like one of the calculations. So the strategy, say for D, right? The strategy for D here is that equation looks like f of x equals 3x to the fourth minus 2x cubed plus 3. So how do you do this problem if this was a homework assignment? So what's the leading term? LT. That would be 3x to the fourth. So you plug x goes to infinity, and you plug that into the leading term. And you see you have no negatives, so that would imply y goes to infinity, right? So if you think about it, that would mean at the end of that graph, it's going to go up that way. So what happens as x goes to minus infinity? Well, that would be 3 times minus infinity to the fourth power. And so when you take something to the fourth power, you multiply it 4 times. So that means we have 4 negatives. 4 negatives turns into a positive. So this also goes to positive infinity. So you could see it goes up that way. So if you went back to our little match game graph, you could see that the bottom one, this is the actual graph of that equation, but you see what happens at the endpoints, right? Not the endpoints, at the ends of each graph. This is going up, as x going to the right, and this is going up as we go really far to the left with x. And so you see the strategy. And so that's the first of many concepts that we're introducing on how to sketch a polynomial equation. This idea of what happens at the two extremes, again, is called end behavior in the book. A lot of other books call it the leading term test. So that ends this part of the lecture, recorded lecture for section 5.1. And I'll probably do one or maybe two more outlining some more concepts dealing with polynomials.